First, let's do a quick picture of y equals 1 over x. Okay. Well, when x is 10 or something like that, that's 1/10, right? It's really small. When x is 1, what's 1 over 1?
1.
1. And when it's 1/10?
It's
X is 10, or Y is 10.
10. So we have something that gets very high near 0 and then gets very low. Does it ever get to 0?
No, it's undefined at 0.
It's undefined at x equals 0,
Yeah.
but does y ever get to 0
No,
as x gets large?
because then when X is infinity, Y would be 0.
Okay.
It just gets really small.
So what's happening to this curve in terms of its slope of this curve as you get farther and farther out on the x-axis?
It kind of will, it will get smaller and smaller.
It approaches 0.
The slope also approaches 0.
Yeah.
So this curve gets really flat, right?
Yep.
Okay.
And is the slope positive or negative?
It's negative, slightly.
Slightly negative and becoming flatter and flatter and flatter. And we said the derivative of 1 over x was minus 1 over x squared. So that's negative, definitely.
Yeah.
Yeah.
And
Normally this is going, for values of X that are relatively big, this is going to be small.
for values of x that are relatively big, it's going to be very small.
Like 10.
Yeah. So 10, the slope should be about minus 1/100th. Okay. Now, we can't tell just by looking at the slope if it's minus 1/100th or minus, even if the slope was minus 1 over x here, we wouldn't know really the difference. Is it minus 1/10? Is it minus 1/100th? It's not obvious from just looking at it. That's where we need the algebra to help. But at least we get the idea here that this slope is negative and going to 0.
Yeah.
Okay? Now let's look at a graph of y equals 1 over x. Or sorry, not 1 over x, square root of x. Okay, so at 1, that's also 1. At 4, it's
2.
2. At 9, it's
3.
3. And at 0, it's 0. So this sort of goes like this.
Sort of looks like half of a sideways parabola.
Well, in fact, is it a sideways parabola?
I think it is.
Okay, why?
Because it's x squared is a normal parabola.
Y equals x squared is a normal parabola, what you're calling a normal parabola. What is this equation?
This is sort of flipped around.
And how would you write the equation in a similar way to y equals x squared?
Was y equals x to the 1/2.
So write it in a similar way to y equals x squared.
So y squared equals x.
Yeah, just square both sides and you get y squared equals x. So you're right, this looks a lot like a parabola lying on its side, and it's because this is really y squared equals x. You square both sides. Okay. And it's only the top half because the square root function
Makes
is
everything
defined to be positive.
positive.
Now what's happening to the slope of this graph? What do you see in the slope of this graph as x gets large?
Well, it's positive, but it's kind of leveling out.
It starts off pretty steep and then
It's kind of like the infinite bridge thing.
It starts out pretty steep and then
It gets really small.
flattens out, seems to flatten out.
Goes
And
to 0.
our derivative was 1 over 2 square root of x.
which
Right, 1/2 x to the minus 1/2.
makes sense.
So as x gets large, like as x is 100, this is 10, right? Square root of x is 10.
Yeah.
So we get 1/20th. So we are getting, as x gets large, we are getting numbers close to 0, and that's what we see here. It's flattening out. And you said it starts out pretty steep. Like when x is small, like 1/100th, square root of that is 1/10. 2 times 1/10 is 1/5. And so when x is 1/10, we have a slope of 5 here. Very steep.
It's pretty steep.
Just what you were seeing.
Mm-hmm.
Okay.
But it's sort of weird because when x is 0, the slope is 1/2.
Explain your logic to me there.
When x is 0, oh no, when x is 0 it doesn't work.
Why not?
Because everything just goes away. It's 1 over 0.
It's 1 over 0.
Makes no sense though.
Right. So in
When
fact,
x is 1, the slope's a half.
When x is 1, the slope is a half. When x equals 0, the slope is not defined because the derivative is not defined at x equals 0. But it does look like as you're getting to 0, it's getting steeper and steeper and steeper. So in some sense, we might say that at 0, the tangent line is this vertical line, the
So the
y-axis.
slope is infinity.
It seems like that's what's happening.
But we don't know, it's undefined.
But you saw this curve and thought, wow, that's really steep near 0. And in fact, naively just plugging in 0 here, we would get infinity, right? So it sort of seems right. So then we would have to be a little bit more precise on what's going on. But anyway, so this is really cool. So
Yeah.
these very simple ideas, these very simple concepts from Grant Sanderson's video allow us to study these functions in ways, just using some very basic algebra, that tell us a lot about how the functions are behaving. It's really cool.
Yeah.
All right, good work, guys.